Welcome to clickmeprojects.com. Here we discuss about abrupt motion tracking via intensively adaptive MarkovChain Monte Carlo sampling. Visual tracking in dynamic scenarios refers to establishing the correspondences of the object of interest between the successive frames. It is a fundamental research topic in video analysis and has a variety of potential applications, including teleconferencing, gesture recognition, visual surveillance, and motility analysis. As an important topic in the computer vision community, visual tracking has been extensively studied in the past decades, and a number of approaches have been proposed. In real world, many tracking tasks suffer from the multimodal likelihood and posterior, high dimensionality and inaccurate local evidence. To facilitate efficient tracking, in general, most existing approaches are based on a smooth motion assumptions or an accurate motion model. However, abrupt motions are common in real-world scenarios such as fast motion, computer switching, low frame rate, and unexpected object dynamic. This is challenging for tracking models, both deterministic ones and sampling-based ones, to deal with the large motion uncertainty induced by abrupt motions. Intuitively, a direct solution for the sampling-based tracking models is to enlarge the sampling areas to cover the possible motion uncertainty. Nevertheless, there exists a problematic issue to be addressed, that is the sampling inefficiency. This is because the increasing in the sampling volume may require a more expensive computational cost, particularly for the system with a high dimensional state space. The success of the particle filter highly relies on its ability to maintain a good approximation to the posterior distribution. For complex filtering distribution with energy landscape, a large number of particles are required to guarantee significant sampling in the broad state shape. The high computational burden caused by the large number of particles often makes the PL infeasible for practical application. Among them, MarkovChain Monte Carlo methods have received much attention in visual tracking. The simplest solution to the abrupt motion problem is searching the whole state space to fully cover the motion uncertainty. Since particle filters and MarkovChain Monte Carlo methods are often suffer from local trap problem. To prevent this problem, here we introduce a SAMC sampling method, that means stochastic approximation Monte Carlo sampling method, into the Bayesian filtering to effective handling the local trap problem. Here, in addition to improve the sampling efficiency, we propose a new MCMC sampler with intensive adaptation. This is done by the combination of SAMC sampling with a density grid-based predictive model. This proposed method is effective and computationally efficient in addressing the abrupt motion problem. Thus, our proposed method was named as Intensively Adaptive MarkovChain Monte Carlo. This is our block diagram. In the first step, we initialize the given video which we want to track. Next, the given video is converted into frames and stored as an image format. In our method of tracking, SAMC sampling system is the first method for IAMC sampling process. In the SAMC sampling, the first method is projects the particles for each and every frames. These particles are used for sampling and tracking further process. The propagated particles in each and every frames denotes the movement of any pixels in the frames. Next, these particles are given to sample proposal. In this process, it provides the sampling process for the projected particles. After the sampling was done, this was given to sample acceptance stage. In this, it checks whether the given sampling output is acceptable range or not. After that, this acceptable sample rate was given to weight updating stage. In this, it checks the weight updation for each and every frames and each and every particles. Here, Bayesian filtering is used for checking whether there was any moving pixels in the projected particles for each and every frames. By using this filter, SAMC sampling process will be done perfectly. The weight value updated from the SAMC sampling process is given to sample reweighting block. In this stage, it reweights the each and every weighted updation. Output from SAMC sampling will get the sampled output from particles. These sampled particles are used for tracking. These are also given to density grid model. In this block, it converts the given frames into 6x6 cells. Then this loop is further given to particle propagation stage, and the SAMC sampling process, it samples the particles, and further these loops are moving for again and again for each and every frames. Then finally we track the moving object in each and every frame. Thus we track the moving object by using SAMC sampling process and by using density grid model. Now I am going to explain the running process of our project. Now run main.m file. This is our GUI window. In the first step, we load the input video by clicking load button. Here the axis displays the given video frames. This video is, we have to track the person. Then after the initialization of video, we convert the given video into frames by clicking frames button. Here that each and every frames are converted into image file format and stored in a frames folder. Here these frames are further accepted to track the moving person. Then we propagate the particles on the frames by clicking particles button. In this stage, the axis in the figure displays the particles propagated in the moving pixels for each and every frames. These particles are further used for sampling, and finally the sampled output reweighting is used for tracking the moving object. Here, these samples output particles will propagate the moving object of pixels. Then the frames are given to density grid model, and in this density grid model process, it gets the weighted output for each and every cells. In the density grid stage, it converts the frames into cells, and it checks the weights for each and every cells, and finally this will gives the tracked output result by clicking density grid model. Here, this figure displays the cell formats for the frames. Then from the reweighted output from density grid model, we track the moving object by clicking track button. The axis in the figure displays the tracking output. Here we using the bounding box to track the moving object. This is done by the sampled output from SAMC sampling and by using density grid model. From each and every frames, it checks the density grid model output, and by using the particles, it tracks the moving object. The bounding box follows the moving object, which denotes the rectangular box. Here the bounding box was done by collecting the clusters of particles which are projected in the each and every frames. Finally, we get the horizontal and vertical values for providing a rectangular box to track the moving object. Thus we track the moving object by using INC sampling method. Thank you.